Let's do a quick review of logarithms before we head into natural logarithms. If we have log to base 2 of 8, what this is asking is 2 raised to what power equals 8? Well, since 2 times 2 times 2 is 8, this one, 2 to the third power, equals 8. So the log to base 2 of 8 is 3. On this one, log to base 5 of 125 is asking what do you raise 5 to get a 125? So 5 times 5 times 5 is 125, so that's 3. In this next one, it says log of 10,000. And when there's no base specified, it's understood to be a 10. So log to base 10 of 1,000 is asking what do you raise 10 to get 10,000? And it would be 4. So just as a quick review, 10 to the fourth power is 10,000. So having talked about logarithms in this manner, let's come up with, instead of these specific examples, we'll come up with a general rule. So log to base b of x is asking what do you raise b to get x? Now let's say that I have log to base e of x. E is a constant. It's 2.71828, and it goes on for an infinite number of decimal places. This is the same as saying ln x. And this is read the natural log of x. And it's understood that this has a base of e here, but it's written in this form. So looking at this, it says natural log of 1. This is asking log to base e of 1. So this is asking e to what power is going to be 1? Well, anything raised to the 0 power, e to the 0 power would be 1. So the natural log of 1, write it like this, is 0. Anything raised to the 0 power gives me 1. Here, I'm being asked, what's the natural log of e? Well, this is the same as saying the log to base e is e. So e to what power will give me e? Well, if I had 4 to the first power, that would be 4. If I had 5 to the first power, so e to the first power would be e. So the answer to this one, the natural log of e equals 1. With this next one, going into exponential form, e to what power is going to give you e to the x? Well, if you think about this, e to the first power is e. E to the second power is going to be e times e. And finally, e to the third power would be e times e times e. So what this is asking is, what do you raise e to get e to the x? It's just going to be whatever the exponent is. So over here it was 1, over here it was 2, over here it was 3, and if we don't know what it is, if it's just x, whatever that exponent is, that's the answer. So e to the x would be e to the x. Now here we're saying the natural log of x equals the natural log of y. Well, in this case, whatever I'm raising e to, that gives me x, and whatever I'm raising e to gives me y, and they're equal, well then x must also equal y. In these next two properties, the natural log of x times y equals the natural log of x plus the natural log of y. Where this comes from is the exponent rule, where if I have x raised to the n power times x raised to the m power, that is the same as x to the n plus m. That's where this rule comes from. And this one, also related to it, if I have x to the n power divided by x to the m power, that's x to the n minus m. So multiplying them is when I add the exponents, and dividing them is when I subtract the exponents. And this last one that we'll look at before we start doing some practice problems is when I have ln x to the k, I can bring that k to the front, and I would have k times the natural log of x. So for our first practice problem, we have the natural log of e to the fourth. Using this rule, I see that the natural log of anything raised to the k power, I can bring the k to the front. So in this case over here, I'll bring the 4 to the front, ln e. And then I just do it in pieces. So this is 4 times, and from earlier we had defined that the natural log of e equals 1. So this is 4 times 1, which is just 4. So here we have natural log of x to the 7th, y to the 5th. This is multiplication, and also we have exponents. So this is going to use the following two rules. So we see in this rule, if we have the natural log of something times something else, that's equal to the natural log of the first plus the natural log of the second. So I'm going to rewrite this as natural log of x to the 7th plus natural log of y to the 5th. Now I can further simplify because when I have an exponent, I can bring that to the front as a coefficient. So this simplified would be 7 natural log x plus 5 natural log y. Now, one thing to note here about the rule, when I go from this form to this form, that's expanding, and they work in reverse. So if I have this form, I can condense it to be this form. Let's try another one. So here we have natural log, and in the numerator is x to the 3rd power, and the denominator is y to the 4th, z to the 2nd. It's going to use these rules. So we see here that if I have the natural log of a numerator and a denominator, that's the same as the natural log of the numerator minus the natural log of the denominator. And we also have combination in the bottom. So we'll just take it one step at a time. It looks ugly, but the truth is it really isn't. So the numerator is the first part. So I'm going to put natural log x to the 3rd minus, and this is going to be in two parts. I'm just going to write it this way for now. So I have natural log of y to the 4th z squared. Now in the next line, I want to simplify this. So I'm going to expand this. So I'm going to bring back the rule for multiplying. So I'm going to copy down the first part here. So I have natural log x to the 3rd minus. Now I'm going to keep the parentheses. Remember, if I'm subtracting, I'm going to have to distribute this minus to both of these terms when I'm done. So the first one is going to be ln y to the 4th plus ln z to the 2nd. Now I need to distribute this minus, so this plus is not going to be here, so I'm going to write natural log x to the 3rd minus natural log y to the 4th, and minus, because this is minus times a positive and a minus times a positive, so now I'm going to subtract ln z squared. And the only part that's left now is here when we have an exponent, we can move it to the front to be a coefficient. I'm going to do that in all three of these terms. So I have 3 natural log of x minus 4 natural log of y minus 2 natural log of z. So what we've been doing is we have been going from the condensed form to the expanded form. Let's, on this one, go from expanded back to condensed. So for this one, I noticed that I have 3 natural log of x plus 7 natural log of y, and it uses the following rule to condense it. And this rule for the coefficient becoming the exponent. So I'm going to now, first I'm going to move the 3 to be the exponent and the 7 to be the exponent. So moving those, I get ln x to the 3rd plus ln y to the 7th. And then going from the expanded form back to condensed, I have natural log of x to the 3rd, y to the 7th. I'd like to make one additional note. So here the exponent is 4 natural log of x. The rule where I can move the coefficient over and it would be the exponent holds true here too. So I can rewrite this as e, and natural log x to the fourth. Now keep in mind that over here, this is an e. And just as if I had 5 log 5 of 125, that these would cancel and the answer would be 125. Well, the same holds true here, that these would cancel, and what I would have for an answer, simply x to the fourth power.